Function notation, lesson 2. Since functions are rules that convert our inputs, which are usually our x's, into outputs, which are usually our y's, it makes sense that they have their own notation to indicate what the rule is, what the output is, what the input is and what the output is. So let's take a look at this first exercise. For each of the following functions, find the outputs for the given inputs. So we're going to find the y's with certain x's. So I'm going to leave you to do A and B because those are simpler. I'm going to give you the answers, but by all means, work them out to see if you get those outputs. Okay. These are the x values as you go through. So those are your inputs. You're going to put them into the function and see what the outputs give you. They should give you the answers that I just gave you. So the example I'm going to walk through is h of x. That's how these are written. H of x, this one is g of x, and this one is f of x. So h of x, my rule says to take the square root of 2x plus 1. So h of 4, so if my input is 4, I'm going to evaluate and get the output for that given input. Now it's just a little mental math here. 2 times 4 is 8 plus 1 is 9. Well, the square root of 9 is 3. So then what about h of 0? So if I have an input of 0, what is the output that goes with that? 2 times 0 plus 1. 2 times 0 is 0 plus 1. So I have the square, sorry about that. I have the square root of 1, which we know is just 1. So function notation can be very confusing because it tends to look like multiplication due to these parentheses that we have here. Okay, but there's absolutely no multiplication involved when we see that notation. We're not multiplying f by -3. That's not what's happening there. The notation serves two purposes. It tells us what the rule is, and to specify an output for a given input. So here's a little summary of function notation. So if my outputs are my y's, so f of x means f is the rule and the input is the x. So an easy way to think about it, y is the same thing as f of x. It's just in function notation. Given the function f of x is equal to x divided by 3 plus 7, do the following. Explain what the function rule does to convert the input into an output. So what's happening here? It says it first divides the input, sorry, the stylus is acting up this morning, by 3, and then adds 7 to the result. Okay, I'm sure you could agree with that looking at that. We take the x, we divide it by 3, we get a number, and then we add 7 to that result. So now let's evaluate f of 6. So my rule says, take my input, 6, divide it by 3, and then add 7 to it. So 3 plus 7 is 10. F of, I lied, that would be 2 plus 7, which is 9. A little early this morning. F of -9. So take that input of -9, divide it by 3, and add 7 to it. So -3 plus 7 gives you 4. Okay? So really nothing new here today, just different notation. You guys know how to evaluate stuff. So it says, find, now this one, let's be careful, because they changed it up. Find the input. So we're going to be looking for the x, for which f of x equals 13. So they've given us the output. They've given us the y. Show the work that leads to your answer. So our rule up here says, okay, my function rule is equal to x divided by 3 plus 7. So we know that f of x is equal to 13. So the y is equal to 13. The output is that we are going to solve this equation for x. So now we can subtract 7. We get 6 is equal to x divided by 3. And we know that that is going to multiply both sides by 3, and we're going to get our x to be 18. This one you have to read very carefully, okay, to catch that that's what they're asking for. So in D, we're sort of nesting some things here. We say g of x, so some new rule, g of x is equal to 2 times f of x, so 2 times whatever f of x is, and then subtract 1. Then what is g of x? Show your work that leads to your answer. So g of 6. So g of 6 is equal to 2 times f of 6, which we don't know that right at this moment, but we do because we did it up here. Oh, look at that in B. So let's continue on. Let's continue to show our work. 2 times, what did we get for f of 6 back up here? F of 6, we found out was 9. So 2 times 9 minus 1. So that's 18 minus 1, which is 17. So we just found g of 6 is equal to 17, where we used a function rule, f, within a new function rule. So it says, recall that function rules come in 3 different forms. We could have equations, we could have graphs, and we could have tables. In 3, we're going to talk about a function rule in a table. So the information says boiling water at 212 degrees Fahrenheit is left in a room that's 65 degrees Fahrenheit and begins to cool. Temperature readings are taken each hour and they're recorded in the table. T is a function of the number of hours, h. So h is my input and my output is the temperature in Fahrenheit. And they've listed hours from 0 to 8 and all the different temperatures. So it says evaluate T of 2. So at 2 hours, the temperature is 104 degrees. And at T of 6 hours, the temperature is 68 degrees. Pretty simple when it's given a table. For what value of h, now be careful, is T of h equal to 76? So a temperature of 76 gives us, or happens, at 4 hours. Okay, so we could say T4 is equal to 76. Between what 2 consecutive hours, consecutive means one right after the other, will T of h equal 100 degrees? So 100, okay, a temperature reading of 100 degrees is going to occur somewhere between 85 degrees and 104 degrees. So what 2 consecutive hours? 2 and 3 hours. So now we have a graph, and this graph is known as a piecewise linear because it's made up of straight line segments. Okay, we have different linear pieces pieced together here. So now we're going to read the graph. F of 1. So where is f of 1? Remember, this is my input, or my x. So go to where f is x is 1, which is right here. Travel up, read the graph, and what is that y value? And that y value is 4. I'm going to give you that one, and I'm also going to give you this one. Go ahead, test it. Okay, and f of 0, again, that's our input. So go to where x is 0, travel up, meet the graph, and read what the output or the y value is, and it's 2. Now it says solve each of the following for all values of the input x that make them true. So again, we're sort of working backwards. We're looking for the x value now that gives us an output or a y value of 0. So where are all the y values? 0. Okay? The y values are 0 are here, here, and there. So what are those x values? The first x value is -1. The second x value right here is 4. And the third one is 4, 5, 6, 7. So let's do that one more time. What are the x values when we get a y value of 2? A y value of 2. So my y values at 2 are all along this line. Right here and right here. So what's the x value that goes along with that? That would be 0. And then this one would be 1, 2, 3. Okay. The last question, what is the largest output? Okay, meaning the y value. What's the largest y value achieved by the function? So what's the highest point on here? The highest point is right there, and that y value is 4. Okay, that's our largest output in this function. At what x value is it hit? So what's the corresponding x value that goes with that? Right there, and it's x equals 1.